Welcome to another episode of Decoding Autism Now. I'm Dr. Elise Martin, and today we're going to dive deep into the critical role of neuroregulatory peptides in autism. If you've been following our series, you know that autism isn't just a behavioral condition, it's a signaling disorder, one that spans from the gut all the way to the brain. In this episode, we're exploring 4 peptides that might just hold the key to understanding autism in a new way. We'll explore how 4 essential signaling peptides are linked to autism spectrum disorder, and what we can do to help restore their rhythm for better health outcomes. We often focus on neurotransmitters, hormones, and genetic factors. But there's something else that plays a crucial role: a group of neuroregulatory peptides. Let's take a closer look at 4 of the most important neuroregulatory peptides involved in autism: C-cretin, motilin, oxytocin, and VIP. These peptides help regulate key systems, and even the timing of biological processes such as digestion, with the release of enzymes at the proper time. They help control and regulate immune function, mood, behavior, and even sleep patterns. Peptides are small but mighty messengers in the body. They control everything, and they're deeply intertwined with how our body systems work together. These proteins are involved in regulating fundamental functions, including the release of neurotransmitters, managing gut function, and even modulating immune responses. Peptides influence how our bodies respond to stress, how we digest food, and how we regulate emotions. In children with autism, these peptides often fail to work in harmony, causing significant disruptions to both physical and mental health. When this happens, systems that are supposed to be well coordinated instead become disconnected, leading to symptoms such as anxiety, digestive problems, and difficulties in social interaction. But what happens when these peptides fail to work in harmony? Let's see what happens when these small yet powerful molecules don't function as they should. Let's begin with C-cretin. C-cretin is a hormone that's released in the duodenum when acidic contents from the stomach enter. This hormone is essential for the proper digestion of food. C-cretin stimulates the pancreas to release bicarbonate, which helps neutralize stomach acid, providing a safer pH environment for the enzymes that help break down food. However, in children with autism, chronic high intestinal pH levels can impair the release of C-cretin. And for C-cretin to be released, the pH must be lower than 4.2, and that may not be the case in children with autism. This means that digestive enzymes, such as pepsin, which are required for breaking down proteins, are not activated as they should be. This disruption causes a cascade effect in digestion, leading to poorly digested food particles that can enter the bloodstream as opioid peptides, fragments of proteins that resemble narcotic-like substances. These opioid peptides have been linked to behavioral challenges in autism, including irritability, mood swings, and repetitive behaviors. Without proper digestion, children are also at risk of malabsorption, which results in nutrient deficiencies that affect brain function. This is a common issue that contributes to the cognitive and emotional difficulties faced by many individuals with autism. Today, there are several labs that can test for opioid peptides in urine. It is a simple and non-invasive test that can be ordered through your medical professional. Next, we turn to motilin. Motilin is a peptide that controls the migrating motor complex, a series of muscle contractions in the gastrointestinal tract. This complex is essential for clearing undigested material between meals and helping the digestive system reset after each eating period. Motilin helps maintain gut motility, ensuring that food and waste are moved efficiently through the intestines. In children with autism, motilin's signaling can become misaligned. This misalignment can result in slow digestion, constipation, and an overgrowth of harmful bacteria in the small intestine, known as SIBO, small intestinal bacterial overgrowth. These digestive disturbances not only impact nutrient absorption, but also contribute to irritability, bloating, and abdominal discomfort, all of which are common in individuals with autism. Moreover, when motilin doesn't function properly, it disrupts appetite regulation, often causing children to either overeat or avoid food. This can result in nutritional imbalances that affect cognitive function and emotional regulation. Addressing motilin dysfunction through dietary interventions, such as intermittent fasting or medications like erythromycin, which stimulates motilin's activity, can help restore more natural digestion and improve both gut health and behavioral outcomes. Now, let's examine oxytocin. Often called the love hormone, oxytocin plays a significant role in social bonding, emotional regulation, and the gut-brain connection. It's involved in facilitating trust and connection between individuals, and it helps stabilize emotions. But oxytocin's role isn't limited to the brain. It also helps regulate gut motility and vagal tone, which is essential for the gut-brain communication pathway. In individuals with autism, oxytocin levels are often lower, which can contribute to social withdrawal, anxiety, and poor gut function. The vagus nerve, which connects the gut to the brain, is deeply influenced by oxytocin. When oxytocin is low, the vagus nerve's ability to facilitate effective gut-brain signaling becomes impaired. This leads to digestive disturbances and exacerbates social and emotional difficulties. Interestingly, studies have shown that nasal oxytocin can temporarily improve social behaviors such as eye contact and social engagement. However, the effects are often short-lived, suggesting that while oxytocin may play a vital role in improving certain behaviors, the underlying causes of low oxytocin signaling require more comprehensive intervention. Boosting oxytocin's effects through strategies like deep breathing exercises, probiotics, or even direct supplementation can be effective in the short term, but more research is needed to develop long-lasting strategies for oxytocin rebalancing. Vasoactive intestinal peptide, VIP, is another important peptide that regulates biological rhythms. VIP is involved in maintaining the circadian rhythm, our internal clock, regulating sleep cycles, and modulating both gut motility and immune function. When VIP is dysregulated, it can lead to disruptions in sleep patterns, immune responses, and stress management. In autism, VIP's function may be underexpressed or misaligned, leading to sleep disturbances and increased anxiety. Disrupted sleep is a common issue among children with autism, and inadequate sleep contributes to hyperactivity, emotional dysregulation, and sensory sensitivities. VIP also plays a role in the body's anti-inflammatory responses. When VIP levels are low, inflammation can build up in the body, particularly in the gut, and spill over into the brain. This chronic inflammation has been shown to exacerbate a range of neurological and behavioral challenges. VIP is critical for the proper functioning of the gut-brain axis, and when its signaling is out of balance, both digestion and emotional health can suffer. Restoring VIP signaling can help regulate sleep patterns, reduce stress, and improve both social engagement and gut function. These 4 peptides, C-creatine, motilin, oxytocin, and VIP, each play a vital role in regulating not just digestion, but emotional and social behavior. When they are out of sync, we see the disruptions that are commonly associated with autism: poor digestion, sleep issues, social challenges, and heightened stress responses. When these peptides are functioning properly, they ensure that the body's systems work in harmony. They support digestion, regulate the immune system, stabilize emotions, and facilitate social interaction. But when their rhythms are disrupted, the cascading effects can be far-reaching, impacting the gut, the brain, and overall well-being. The real question we need to ask is, how do we restore their rhythm? How can we help the body systems get back in sync so that children with autism can thrive? Fortunately, there are steps we can take to help restore the natural rhythms of these peptides. Clinical interventions that focus on improving the function of these peptides can lead to significant improvements in gut health, social behavior, sleep, and emotional regulation. Here are some therapeutic interventions to consider. For C-creatine, betaine HCl or pepsin supplements can help stimulate digestion and lower intestinal pH, facilitating the proper release of C-creatine. For motilin, fasting intervals or erythromycin, used off-label, may help activate the migrating motor complex, improving gut motility and reducing constipation. For oxytocin, nasal oxytocin, Saccharomyces boulardii, a probiotic, and deep breathing exercises may help improve social interactions and gut function, promoting better emotional regulation and social engagement. For VIP, light-dark regulation, anti-inflammatory therapies, supplementation with curcumin and resveratrol, and sleep scheduling can help restore the body's circadian rhythm, leading to better sleep quality and reduced anxiety. These therapeutic interventions address the root causes of peptide dysregulation, providing support for the body's natural rhythms and helping to restore balance. With the right approaches, we can help children with autism experience improved health outcomes and a better quality of life. The key to managing autism symptoms lies in restoring balance, not just adding more therapies but understanding the rhythm of the body. By resynchronizing the peptides that regulate digestion, social behavior, and emotional responses, we can help individuals with ASD function more naturally and harmoniously. Thank you for joining me on this exploration of neuroregulatory peptides in autism. I'm Dr. Elise Martin, and I hope this video has provided you with insight into the complex but fascinating world of ASD. If you learned something new, please like this video, share it, and subscribe for more in-depth content on autism and health. Medical disclaimer: this content and other content on this channel is for informational purposes only and should not be considered medical advice. Always consult with a healthcare professional before making any changes to your health or treatment regimen. Final thought: sometimes, the smallest biological rhythms, like those of neuroregulatory peptides, can have a profound impact on our health. By restoring harmony within these systems, we pave the way for a brighter future, where individuals with autism can thrive with greater ease and resilience.